Hello, I hope you're doing well. Today we're going to have another lesson on unit circle and special angles. Please remember to like and subscribe if you enjoy this stuff. Now let's get started. So we're going to be looking at the unit circle and how to generate the unit circle pretty quickly. We're not going to spend a lot of time to actually go through this, but firstly we need to understand why this thing is called a unit circle. It is called a unit circle simply because the radius of this circle here is 1. So if you're doing pre-calculus or you're doing AB Cal or whatever course that you're doing, you're going to be required to be very comfortable with the unit circle. So the first thing that we're going to do, we have some special angles here that we want to be very comfortable with. The first one here going to simply be 30. These are the special angles, 45, 60, and then 90. So those are the special angles. So 30, 45, 60, 90. Those are the special angles. Now, once you have these special angles, you need to be very comfortable with what the coordinates are going to be. If it's a unit circle and I'm going to the right, this is obviously going to be 1, 0. This at the bottom going to be 0, negative 1. It's at the top going to be 0, 1. And to the left right here going to be negative 1, 0. Now, one important thing that you need to do, we just need to know the first quadrant and understand what is going on right here. The distance between the first and the x-axis is going to be 30. And then for the last right here in the first quadrant, going to be 30 again. So if you check this pattern, this is going to be 30, 15, 15, 30. So it's going to be the same thing going all the way around. So the first piece right here, if I add 30 to 90, I'm going to get 120. If I add 15 to 120, I'm going to simply get 135. And if I add 15 to 135, I'm going to get 150. And if I add 30 to 150, I'm going to get 180. Doing the same thing again, add 30 to 180, we're going to get 210. Add 15 to 210, I'm going to get 225. Add 15 to 225, going to give me 240. And then add 30 to 240, going to give me 270. So that's a pattern. Adding 30 again to 270. Let me use a different color right here for this last piece. So adding 30 to 270, simply going to be 300 right there. Add 15 to 300, going to be 315. Add 15 to 315, going to be 330. Add 30 to 330, obviously going to give me 360, and that completes my revolution. Now you can do the conversion between degrees and radians, but for now, we're going to keep this in degrees. Now we need to figure out the first quadrant. The easiest way to remember this is a quick little method to remember this. If I may erase that, I already know that the top is 0, 1, and the bottom right here, the right here, going to be 1, 0. But what I'm going to do, I'm going to do 0. Start off pretty much easier way if I do this. Parentheses 2. Then I'm going to have 2, comma, put everything over 2. Everything over 2. It's an easy way to remember this. And then I'm going to put everything over 2. Now to do this, all I simply need to do now, I'm going to take the square root, but I'm going to come from 0, 1, 2, 3, 4. And then I'm going to repeat the order, 0, 1, 2, 3, 4. And that will complete my unit circle in terms of identifying the different terms. Now, all I need to do to simplify, I know this right here already going to be 1, 0. Right? I know this term right here. Let me just put it a little bit down. Going to simply be the square root of 3 over 2, 1 over 2. And then I know that the square root of 1 here going to be 1. And then I simply know that the square root of 4 over 2, well, we already know what this is. This is simply 0, 1. Now, the thing here that we need to be keen on, all the other quadrants, the same thing will apply if I start from x going this way. So all I simply need to do is rewrite the first quadrant information back in all the other quadrants. So let's go over here. If we do this quadrant over here, starting from the x going this way, I'm going to be doing the same thing. So this here going to be the square root of 3 over 2. This is going to be 1 over 2. The next one going to simply be the square root of 2 over 2. Square root of 2 over 2. And then this is going to be 1/2 square root of 3 over 2. Now in this case over here, I realize that my x going to be negative. So this is going to be negative, negative, negative. So my x's are negative in that quadrant. I'm going to write now the same thing in the other quadrant right here. So that was quadrant 1. That's quadrant 2. Now I'm going to do quadrant 3, going in the same direction, using this again in the same way, starting from the x. I'm going to get the square root of 3 over 2, 1/2. Right, I can just put this in. I know that both going to be negative in this case. Then I'm going to have the square root of 2 over 2, square root of 2 over 2, both negative. And then I'm going to have 1/2 square root of 3 over 2, both negative, negative, negative. Now again, just remember right here that I'm just writing back the same thing in the first quadrant. So once you got the first quadrant, all the other quadrants is the same thing starting from x. So go this way again is the same thing. I'm going to put right here square root of 3 over 2, 1/2 square root of 2 over 2, square root of 2 over 2. And then the last one going to be the square root. Sorry, it's going to be 1 over 2 square root of 3 over 2. Here, y is negative. So negative, negative, negative. Good. So in that case, my y is going to be negative. So that completes the unit circle. Once you get the first quadrant, all the other quadrants are going to be the same. Now we're going to use this to find some special angles. Now if I draw the unit circle again, and I draw something looking like this, let's come right across. If I put a triangle right there and put it down here, I know that the length from here to here, which is my radius, is going to simply be equal to 1 because it's a unit circle. Let's hypothetically now represent, if I draw a triangle from the center like that, this here going to be my x and this here going to be my y. Now if I recall, I know that sine theta going to be opposite over my hype, if you guys remember this. Cos theta going to be my adjacent over my hype, and tan theta going to be opposite over my adjacent. Now if I have this as my x and that is my y, I know if I'm considering this angle, my opposite going to be y and my adjacent going to be x. So if I want to represent tan theta, I could simply have the opposite over the adjacent, which is going to be my y over my x. And then for sine theta going to be my opposite over my hypotenuse. So my hypotenuse is 1, so that's why I have a 1, which is just y. And cos theta going to be my adjacent, which is x over my hypotenuse, which is 1. So tan, sine, and cos are as follows. So tan going to be y over x, sine going to be y, and cos going to be x. Now, why is this super important? If I look now at this triangle and I put these triangles in, let's look at this. If I do sine of 30, I know sine, if I back up, sine is simply going to be y. So sine of 30 right here for the first one, y going to be 1/2. If I need now cos of 30, cos, if I go back, going to be my x. So my x for the first triangle that I draw, if I'm looking at 30, going to simply be equal to the square root of 3 over 2. So I have sine and cos. Now to get tan 30, all I simply would need to do is divide sine by cos. So this is going to be 1/2, divide by 3 over 2. This here going to be equal to 1/2 times 2 over the square root of 3. That reduce, I'm going to get 1 over the square root of 3 multiplied by the square root of 3 times the square root of 3. This is going to be the square root of 3 over 3. And that is how I would figure out the special angles using the unit circle. I hope you enjoyed the lesson. If you enjoyed the lesson, click like and subscribe, and